So today we are going to learn the first assignment of in animation, that is called the bouncing ball. Bouncing ball is the first step of all the animation you do, either it's a 2D animation or a 3D animation. Once you know how to do the bouncing ball, the rest of the any complex animation you can easily do. This bouncing ball covered the following points we are going to cover in this tutorial, that is the physics, animation principles, and how the software works for the animation. Basically, for every movement, every motion, there is a physics. Behind every motion, there is a physics. Okay. Then it comes the gravity, acceleration, and the mass. Gravity, it shows the motions and the speeds. Acceleration is the how the object moves and how it goes slow. That's the acceleration. And mass, it depends the weight of that object, and with the weight of the object, how it moves. And following animation principles we are going to cover, that is a scratch and stretch, is in, is out, arc, and timing. And then laterwards in software we are going to see how to edit the animation, whatever we have done in the animation in the Maya, and we will tweak the animation through the graph editor. Now what is animation principles? First understand the animation principles. Actually there are the 12 animation principles. To do the animations, to get the perfect animation, you have to follow the animation principles. Animation principles, you get exact motion of the for the object. Animation principles, what we are going to see in this bouncing ball is the first scratch and stretch. What is scratch and stretch? Scratch and stretch is a way of deforming an object such that it shows how rigid the object is. Now for example, if a rubber ball bounces and hits the ground, it will tend to flatten when it hits. Okay, when a rubber ball touch to the ground, because of the force of the gravity, it's hit to the ground, it gets a little bit scratched. And the same time, when it's bounce up again, because of the scratch, it get a stretch. It will be the stretch in the direction it is going. It's like the Newton's law. Every action has an equal and opposite reaction. So it's based on that scratch and stretch happen. When any object hits to the ground, it get a scratch, and it again bounce back, it get a stretch. That is happen to the rubber ball or a softball. But if the property of that object is a heavy, like it has a mass, that is, if it's a metal ball, it will get a scratch or it will get a stretch, maybe some little bit, but depend on the mass of the object, your scratch and stretch principle gets worked. And an important point about the scratch and stretch is that no matter how an object deform, it should still appear to retain its volume. The most obvious uses in character animation is the muscles. When a muscle is contracted, it will scratch, and when extended, it stretches. It is like when you are jumping from one position to the other position, you get a scratch, and then you get stretch to make a high jump. That is called the scratch and stretch. So this is your scratch and stretch example. You can see this balls in its original shape, but because of the gravity, when it's coming toward to the ground, it gets a speed. And when it's hit to the ground, it get a scratch, and when it moves back, it get a stretch. This portion is called the stretch, and again it's going up to a certain position. When it's reached to a certain position, it's become again to the original shape, and same thing happened when it's again falling down, and again it's going up. This is called the scratch and stretch principle. Next is a ease in, ease out. Ease in and ease out has to do with gradually causing an object to accelerate or come to rest from a pose. For example, a bouncing ball tends to have a lot of ease in and out when at the top of its bounce. As it goes, gravity affects it and slows down, and it starts its downwards motion more and more rapidly is out until it's hit to the ground. It's like when the object is falling down, it's coming very fast, that is, it's coming very rapidly, it is called as the ease out. But once it's bounced back and it's going up, because it's going up, it's going against the gravity, because gravity means it's always falling down, but when it's bounced back, that is, it's going up, so automatically the force is getting more force and up, it's contradict to the gravity, so its speeds get slow, that is, it gets slows down, that is called the ease in. See, when it's falling down from the upwards, it has a more speed and the more gap and it get a squash. So is in is out, like it's a slow in slow out. Like when a car starts, it start with the slow, then it speed up, and while it's stopping it get a slow. That is called the is in is out. Okay, next animation principle is the arcs. Any movement it's happened in a real world, almost it's in an arc. When creating any animation, one should try to have the motion followed curve paths rather than the linear ones. See, even if we move our hand, it moves from front to back in a arc shape. Even when we move our body while walking with rhythm, it moves in a arc. It never moves in a straight, except there are few movements which has a straight. But most of the movements happens in the arc. So arc is the one of the animation principle. So you can see the action path of the bouncing ball. It's falling from top, it's coming down, and it's again getting a bounce back up and again falling down. So here you see the arc. This is the action path of the ball. Path of action. It's falling down, but it's getting the movements on the arc. Alright. So even we swing on a swing, so the movement always you get the arc. So this is the fast movement, this is a slow, and again slow, like a movement of a pendulum, and it also moves in a